All right, we have a theorem here that says the limit as n goes to infinity of our a sub nth term equals L. Then if you do that same limit, but there's a function of that sequence, then your limit would equal that function evaluated at this L. So what you can do is, and this is good if your sequence resides in another function here, is that you can basically take the function evaluated at that limit of a sub n, which we know this ends up going to L. So then that means you just end up with your function evaluated at that limit value. So this is good when there's functions involved. Let's look at an example. So number 8 here, find this limit here. Well, we don't know what the limit as n goes to infinity of sine of this is, but if we just focus on the inside part, we could certainly do that. So what we're going to do here is sine pi over n. So what we're going to do here is say this is going to be equal to then sine of the limit as n goes to infinity of pi over n, and see what that equals. Well, what is the limit of that? Well, pi is just a constant here, so we could also think of this as pi times the limit as n goes to infinity of just 1 over n. And we know that that limit is going to be 0. So what we end up with here is that this is going to be sine then of pi times 0, which is then just sine of 0. And then now, since we know that limit ends up approaching 0, if we just take the sine of that value, that sine of 0 ends up being just 0, and so the answer is 0 here. So that would be the value of this limit. Okay. All right. So let's take a look at one more here. Discuss the convergence or divergence of this sequence. I threw this one in there because this is going to be something you see throughout the year. We talked about this before when you did a little bit of probabilities, called factorial. So n factorial, recall, is equal to placing the numbers from 1 all the way to whatever that n is. So it'd be 1 times 2 times 3 times 4 times 5 times 6 times all the way up to whatever that n value is. So if you had like 6 factorial, that's equal to 1 times 2 times 3 times 4 times 5 times 6. And we'd stop there because that's the number we're taking the factorial of. Okay. So what is this sequence? This sequence, if you were to write it out, we're going to do this as a limit here. What's the limit as we go to infinity of n factorial over n to the n? Well, writing this out would look like this. This would be on the top, 1 times 2 times 3 times 4 times 5, all the way out here to n. N to the n power, what would that look like? Well, that would be n to the first one would be n to the first power, which is just n. And then times n times another n times n. So this would just be n times itself n times whatever that would be. So that's what n to the n power would end up looking like. So what is this? What is this going to be approaching here as we go to infinity? Well, one way you can look at this one would be to use some of those multiplication powers since we're multiplying here. Let's think of this. I'm just going to take this first one out here. This would be the same as 1 over n times, times another limit. As n goes to infinity of the rest of this. So 2 times 3 times 4 times 5 all the way to n. And then on bottom, if I took one of those n's out, I still got all these n's being multiplied together. Now we just have n minus 1 times here that they'd be being multiplied together. So what does this one equal? Well, that first limit we know evaluates to 0. As long as this other limit doesn't go to infinity where we'd have an indeterminate form, we should be able to know then what this would equal. Well, at most, this stuff in parentheses right here should end up being 1, because you can see like 2 is going to be less than 3 is going to be a little less than that. 4 should be a little less than that. So at most, when we have n over n divided there, that's 1. So this value is going to be some kind of constant here that is less than 1. So 0 times a constant means this is going to evaluate to 0. So we know that this one would approach 0. You could, this is one, I think we could try graphing out too with your calculator. So if you put this one in here, you can do n, and then the factorial button is in here. If you go to math and go to probability, or top menu, the last one there, probability, there it is at number 4. I hit the wrong thing there. Let's try that again. Math, probability menu number 4. There we go. N factorial divided by n to the power of n. And let's graph that one. So you can see there's our points there, and they are decreasing here towards 0. So there's the points there. You can see that they're decreasing towards 0.